Welcome to Spaceverse, your portal to cosmic adventures. Before the James Webb Space Telescope embarked on its mission to uncover the most distant and ancient mysteries of the universe, Paul Geithner, NASA's Deputy Technical Project Manager, shared a bold thought. "I think the greatest promise of the James Webb Telescope is that it will provide answers to questions no one has even thought of yet." Fast forward to today, and it's safe to say he was spot on. Now we're left scratching our heads, marveling at how Webb has managed to detect structures in space that seem totally impossible, defying the models we've trusted for so long. But how do we handle discoveries that are so mind-boggling they challenge our very understanding of cosmology? There's been a lot of buzz lately about how Webb might be rewriting the book on everything we thought we knew about the cosmos and the Big Bang itself. But has our entire grasp of the universe been shattered? Not quite. The truth is a bit more exciting and nuanced than that. To put Webb's remarkable power into perspective, imagine this. In theory, this $10 billion marvel could detect the heat of a bumblebee on the surface of the moon from Earth. But instead of finding tiny insects in the vastness of space, Webb has uncovered a whole range of mysterious objects that just don't fit into our traditional models of the universe. And that's where the real fun begins. First up, we have the mind-blowing universe shakers. When Webb's near-infrared camera peered at a section of the sky near the Big Dipper, experts noticed 6 reddish points of light in the images, which turned out to be truly baffling. Using redshift data, scientists at Swinburne University of Technology in Melbourne figured out that the light from these objects had traveled over 13 billion years to reach us. This means we're looking at structures that existed only 500 to 700 million years after the Big Bang. Even more intriguing, the characteristics of these light points suggest they're very early galaxies that shouldn't even exist in this form yet. Astronomers had expected to find only tiny, baby galaxies from this stage of the universe. Our current models suggest that at this point in cosmic history, there just wasn't enough normal matter to form galaxies as massive as our Milky Way today. So when they discovered that these 6 galaxies already contained over 10 billion solar masses of stars, the scientists were stunned. One of them might even have more than 100 billion solar masses. There are 2 main ways to explain the presence of such massive early galaxies. Either the matter density in the early universe was much higher than we thought, 2 to 5 times greater, or these galaxies formed in a completely unexpected way. So, have these universe-shattering discoveries been solved? Unsurprisingly, experts have called these puzzling findings a real dilemma for science. Due to their baffling sizes, these structures quickly earned the nickname universe breakers. However, these discoveries didn't stop there. They set the stage for even more puzzling revelations that cast serious doubt on our understanding of cosmic evolution. Just a few months ago, Webb made another astonishing find with JWST 14, adding a new early galaxy to the star map. This galaxy existed only 290 million years after the Big Bang and turned out to be yet another astronomical enigma. Even though this galaxy formed at a time when, according to current theory, the first stars were just starting to form, it is already far brighter than expected. Research showed that it contains several hundred million solar masses of stars. But how could such a massive galaxy form in under 300 million years? Scientists believe the star cluster took around 100 million years to reach its current size, and spectroscopic studies indicate that multiple generations of very massive stars have already lived and died in this galaxy before it caught astronomers' attention. So, what do these strange discoveries mean for the bigger picture? If we were wrong about how galaxies form, could we also be wrong about more fundamental ideas, like the birth of the universe itself? Well, we're not sure yet, but surprisingly, the greatest astronomical crisis of our time might be turning into a promising breakthrough, at least in part. Recent research suggests that the mysterious red light is not coming from unexpectedly star-rich galaxies, but rather from active black holes located at the centers of these early galaxies. These massive black holes, with their immense gravitational pull, draw in matter, which forms accretion disks around them. These disks, made up of hot gas and dust, spin at astonishing speeds of up to 1,000 km/s around the black hole. Anthony Taylor, a co-author of the study from the University of Texas, explains that this discovery finally resolves a major problem that has long puzzled our understanding of the universe. NASA also weighed in, reassuring the public that despite the sensational headlines, cosmology has not collapsed. But does this mean that our standard model is completely off the hook? Not exactly. The findings from Webb's extensive surveys, covering several 100 million years, show that about 70% of the red exhibit signs of gas movements typical of black holes. However, the remaining 30% are a different story altogether. Moreover, the black holes themselves still raise many questions. While they appear to have formed in large numbers around 600 million years after the Big Bang, they then mysteriously started to decline about 900 million years later. One possible explanation for this is the idea that as star formation progressed, the amount of dust and gas gradually diminished, causing the light emitted by these objects to shift from red to blue. This shift would move the light into a spectrum that the James Webb Telescope can't detect. While this theory is plausible, it still needs to be confirmed in future studies. However, it's important to remember that these so-called universe breakers aren't the only puzzles Webb has uncovered in the cosmos. While black holes appear to hold the key to understanding this mystery, they're also presenting more challenges for astronomers. For instance, there's the perplexing case of an incredibly massive black hole, over 1 billion solar masses, existing just 770 million years after the Big Bang, when the universe was still in its early stages. Does this mean the Big Bang theory is wrong? Could it be that the universe's history is vastly different from what the Big Bang theory suggests? According to the Big Bang theory, the universe originated from an incredibly small point about 13.8 billion years ago, with space, time, and matter emerging from a singularity. Although the Big Bang theory has long been a cornerstone of cosmology, more and more researchers are starting to question this long-standing idea. Among them is British physicist and Nobel laureate Roger Penrose, who doesn't view the Big Bang as the absolute beginning of everything, but rather as an explosive transition between two cosmic eras. Penrose is convinced that the universe follows a fixed cycle of destruction and rebirth. According to his theory, the universe expands until all matter disintegrates into light. In this extreme environment, where time and space lose their meaning, a new Big Bang would inevitably occur, restarting the cycle again and again. While this idea sounds fascinating in theory, here's the intriguing part. Penrose claims to have found tangible evidence for this model. Specifically, he points to unusual circular spots in the cosmic microwave background radiation, which were detected in data from the Planck and WMAP satellites. To clarify, the CMB is radiation left over from the universe's early days, created about 380,000 years after the Big Bang during the recombination period, and it still fills the universe today. Penrose believes that these circular spots, known as Hawking points, are relics from a precursor universe. He suggests that when black holes fully evaporate into Hawking radiation at the end of a cosmic cycle, they carry all their radiated energy into the next universe in the form of these Hawking points. Given the exciting discoveries and the cosmological anomalies revealed by the James Webb Telescope, could it be that our universe isn't the one and only, but rather just part of a current cycle? That's the very question, and not everyone in the scientific community agrees with Roger Penrose's ideas. Whether it's the Big Bang, a cyclical universe, or something entirely different, the truth is that some fundamental questions remain unanswered. After all, what caused the universe to emerge from nothing 13.8 billion years ago, or perhaps even earlier? Was there a trigger, or was it all just a coincidence? And what existed before that? These are still open questions with no clear answers. But who knows? The next big breakthrough could be just around the corner, waiting to be uncovered by another groundbreaking Webb discovery. And that's it. Thank you for joining us on this incredible journey through the universe. From the mind-blowing discoveries of the James Webb Telescope to the big questions about the origins of our cosmos, there's always more to uncover. Don't forget to like, subscribe, and stay tuned for more from Spaceverse. See you next time.